Hello, college biology. This is our first cell membrane video, and we're going to tackle fluid mosaic model. Fluid mosaic model has two divisions, fluidity and the mosaic component. We're going to handle fluidity first. Well, the primary component of the fluidity, and I've discussed this before because it blows my mind every time I think about it, is that this phospholipid bilayer that the cell membrane is made of, its parts are not connected to each other. There is no connection between these. They are just kind of loosely, partially charged, magnetically attracted to each other, which gives us the hydrophilic polar region, the hydrophobic nonpolar region, and the hydrophilic internal polar region. Not connected. That gives it this give and fluid oceanic, wave-like motion. If I poke the cell, it doesn't burst immediately or rip or tear because it has this give because of these weak connections between those molecules. It's pretty freaking crazy. Not only is it made of unconnected parts, these parts move, and they move constantly. And this is a failure of all of the models that you've been exposed to so far. These pictures, they don't move, so they don't tell you a story. And even the videos that do it well, they give you the hey, it's a nice rolling cell membrane type of thing. You feel like you're at the ocean. Okay, that feels great. But we're still missing a major component, and that is the phospholipids themselves move. They swap places with each other. This one will swap with this one, and this one will swap with this one. So their neighbors will swap with each other. How often do they do that? 10 million times a second! It's happening all the freaking time. Right here, cell membrane. Cell membranes. They don't even stay. They don't even stand in a row. Okay, so it's one thing to not be connected, but they don't even stand in a row. They're flipping out all the freaking time. During the time I snapped, it happened like 30 million times. Okay, so it's ridiculous. Ridiculous. Now, there's another type of movement that the phospholipids will undergo, and that is scientifically referred to flip-flop. And that means that this phospholipid will occasionally change which layer it is in to the other phospholipid. This happens much less frequently. And the reason why it happens so little, as they have indicated approximately once per month, is that when we're comparing these motions, over here, the polar side is always staying with the polar side, and the nonpolar side is always staying with the nonpolar side, so there's no tension. But here, you have to get this polar head to pass through the nonpolar region to flip to the other side. That's going to be a difficult thing to convince this polar head to do. It's attracted to these other polar. It doesn't want to mix with the nonpolar, so this happens with a much less frequent occurrence. That is not all that contributes to fluidity, however. Some cells really need to stretch and pull and move their cell membrane. Some of them eat stuff by surrounding the cell membrane and enveloping it, doing that phagocytosis. Well, if you're going to be like some kind of amoeba and you're using your cell membrane with pseudopoda and you're like, I'm going to move out that way, and so I'm stretching my cell membrane out in that direction, you're going to want to have more fluidity in your cell membrane. If you're a cell that's like, no, I'm cool, I'm just sitting here, I don't need to do anything, that's fine, you're going to want to have less fluidity in your membrane. So how do we manage that? Well, if you have more cis fatty acids in your modified diglycerides, in your phospholipids, then you create more space in the cell membrane, which increases fluidity. So if you are a cell that has to push your cell membrane out and move around, maybe you're a single-celled organism, you want to get over there, that's fine. Now, if you're just a skin cell and you're like, no, we're cool right here. This is me, I'm staying right here, I'm going to attach to these other cells around me, and we're just going to be cool right there. Maybe you don't want that much space, so you use saturated fatty acids in your phospholipid bilayer, and so now you have much less fluidity. So now let's transition. We're at minute 431. We're going to call it. We're going to make the mosaic part of this a second video. So cell membrane, fluid mosaic model, fluidity. We'll do the mosaic component later. I hope this helps. Struggle well.